this video, we're going to review for our first one of two quadratics tests. So, in the very beginning of this unit, we graphed in standard form. Remember, standard form is ax squared plus bx plus c. Right? Anytime it's in standard form, we're going to start by finding a, b, and c, or identifying. So my a is 4, my b is 16, and my c is 10. Okay, then I got to find my axis of symmetry. Remember, your formula is x equals negative b over 2a. Right? Negative b would be negative 16. 2 times a is 2 times 4, 8. Negative 16 divided by 8 is negative 2. So I can go on my graph to negative 2 and put my dotted line. That's the middle of my graph. Once I know the axis of symmetry, I can plug it in to find my vertex. So I can do 4 times negative 2 squared plus 16 times negative 2 plus 10. So negative 2 squared is 4. 4 times 4, 16. 16 times negative 2 is negative 32, and then the plus 10. 16 minus 32 is negative 16, plus 10, negative 6. So my vertex is at negative 2, negative 6. So I can go on my graph to negative 2, 3, 4, 5, 6, right there. That's 1 point. I need 3. So to get my other 2, I'm going to use my y-intercept. Well, my y-intercept is always my c value, which means my y-intercept is at 0, 10. So just up here, 2, 3, 4, 5, 6, 7, 8, 9, 10. And to get my last point, I'm just going to reflect that across the middle of my graph, my axis of symmetry. So it's 2 away, so I'm going to go 2 on this side. There's my 3 points, and here's my not so great parabola. Domain and range. The domain for every quadratic is all real numbers. The range always uses the y value of the vertex. So for this one, I don't have any y values out in the bottom. They do not start until negative 6, and then they go up forever. So my range is negative 6 to infinity with a bracket around the negative 6. We also graphed in vertex form. Right? It's called vertex form because it gives us a vertex. Remember, it's normally a times x minus h squared plus k, and my vertex is at hk, where h is opposite sign. So here, my hk would be negative 5, negative 3. So I can go on my graph to negative 5, negative 3. Looking at my a value of 2, that tells me 2 things. 1, that it opens up. And 2, it's stretched because 2 is greater than 1. So that means that normally my graph might look like this. There's my dotted line. But because I'm stretching it, it's getting skinnier. So mine's going to be skinnier than what it would be otherwise. Domain of every quadratic is all real numbers, negative infinity to positive infinity. And the range, this one also opens up. So I'm starting at negative 3 and I'm going up forever. To positive infinity. We put a bracket around the negative 3. After we graphed, we started looking at the solutions, okay, and what type of solutions we can have and how many, right? We use a discriminant to figure this out. So we would look at b squared minus 4ac. Remember, it can either be positive, negative, or 0. If it's positive, you've got 2 solutions. Negative, you've got no real. And 0 means you have 1 solution, and then it's just a matter if it's rational or irrational. So I'm going to find a. Before I find a, it's got to be set equal to 0. Right now I've got this 5 on the other side, so I've got to subtract it over before I can do anything. So I have 2x squared minus 11x plus 2 equals 0. Now I can look at a, b, and c. A is 2, b is negative 11, c is 2. So I'm going to do b squared minus 4ac. Well, b squared is 121 minus 4 times a times c. 4 times 2 is 8. 8 times 2 is 16. This stays negative. 121 minus 16 is 105. 105 is positive, but it is not a perfect square. The square root of that would be just over 10, but it would be a decimal. So because it's not a perfect square, this tells me I have two irrational solutions. And for this one, I'm going to solve using the quadratic formula. Remember the quadratic formula? We have that great song. So we got negative b plus or minus square root b squared minus 4ac all over 2a. Right? Again, I can't solve it like it is, so I had to move that 5 over. It's the same equation we were just working with. And we said that a was 2, b is negative 11, and c is 2. So I'm just going to start plugging in. Negative b would be negative 11, which is just positive 11. Plus or minus the square root. We already did b squared minus 4ac and got 105. And 2 times a is 2 times 2, which is 4. Now I can't take the square root of 105, so I can't split up and do a plus and a minus. But I can try to simplify the square root of 105. Okay, so I know that 5 goes in there, and it's 5 times 21. And then 21, I've got 3 and 7. And all of those are prime. I can't break them down anymore. Alright, because that's prime, I have nothing to circle. I have no groups of 2, which means I can't take anything out of my radical. So this is as simple as my radical gets, which means that my final answer is just 11 plus or minus the square root of 105 all over 4. After we solved, we started factoring. Factoring is another way that we can solve. The first thing we always have to look for is a GCF. So if I want to factor these two, start at the beginning. GCF, 4, 6, and 12, my GCF is 2. To pick the variable, as long as everything has an x, you're going to pick the x with the smallest exponent, which in this case is just x to the first power. They all have y, so my smallest one is just y. And they all have z. The smallest one is z to the first power. Then I just divide. 4 divided by 2 is 2. X squared divided by x is x. Y to the 5th divided by y. Y to the 4th. Z divided by z, it goes away. Negative 6 divided by 2. Negative 3. X divided by x cancels out. Y cubed divided by y is y squared. Z to the 4th divided by z is just z cubed. 12 divided by 2 is 6. My x cancels, my y cancels, my z cancels. So that's all I can do. You can double check. These terms inside the parentheses should have nothing in common, which they don't. They do not all have variables, and they do not all have a number that goes into them. This particular one with multiple variables, we can't factor it anymore, so that one's done. The next one, I've got 4 terms, looking for my GCF first, 8, 28, 2, and 7, got nothing, and then this 7 doesn't have an x, so I can't take out a variable either. 4 terms means I'm grouping. Cut it down the middle. On the left side, 8 and 28, my GCF is 4, x cubed and x squared, x squared. When I take that out, 8x cubed divided by 4x squared is 2x. And 28x squared divided by 4x squared is 7. GCF with 2x and negative 7 is just 1. There's nothing that goes into them. And then I've got 2x minus 7. My parentheses are the same, so that's one of my factors. And then everything that's left over is my other factor. So I've got a 4x squared and a plus 1. Double check. This one is as simple as it gets. This one, it's addition, so I can't do difference of squares. So that's as simple as I can go. Then I've got 4x to the 10th minus 9y squared. So I've got to look for a GCF. One's x, one's y, 4 and 9, so I don't have one. 2 terms, I'm looking for difference of squares. So I've got to have subtraction, which is subtraction, and I've got to have perfect squares. 4 and 9 are both perfect squares, and if it's a variable, it's got to have an even exponent, which both of these do. The square root of 4x to the 10th is 2x to the 5th. Just cut your exponent in half. Square root of 9y squared is 3y. Now I'm just going to plug it into my pattern. I've got 2x to the 5th plus 3y, 2x to the 5th minus 3y. Double check, make sure I can't do it twice. The plus, I can't simplify. The minus, they're not perfect squares, so that's as far as I can go. Then I've got 2x to the 8th minus 162. Always look for the GCF, which in this case is 2. So then I'm left with x to the 8th, and half of 162 is 81. Now I've got two terms, so I'm looking for difference of squares. It's subtraction, even exponent, perfect square. So the square root of x to the 8th is x to the 4th, and 81 is 9. So I've got x to the 4th plus 9, x to the 4th minus 9, and I can't forget my 2. We've got to double check. X to the 4th plus 9, I can't simplify it anymore because it's addition. X to the 4th minus 9. I've got two terms, subtraction, even exponent, perfect square. That means I can do it again. The square root of x to the 4th is x squared, and 9 is 3. So this parentheses right here breaks down again to x squared plus 3, x squared minus 3. I'm not done though. I can't forget the first half of my factoring. So I got to bring down the 2 and the x to the 4th plus 9. Now I'm done. Then we did trinomials, okay? When a is 1, all I have to do is find numbers that multiply to c and add to b. So I'm looking for two numbers that multiply to 9 but add to a negative 10. Well, my factors of 9 are 1 and 9, and 3 and 3, negative 1, negative 9, negative 3, negative 3. Negative 1, negative 9 is what's going to give me 10. So I just plug it into my parentheses. Same thing over here. I want to multiply to 7, add to negative 12. So I've got 1 and 7, negative 1, negative 7, and that's it. 1 and 7 is 8, negative 1, negative 7 is negative 8. So that just means that this is not factorable. There are no factors of 7 that will get us to negative 12. In factoring when a is greater than 1, we've got two options, bottoms up and reverse box. So first I'm going to look for my GCF, 8, 26, and 7, there's nothing. So I'm going to do this one with bottoms up. So I've got to first take my a and make it part of my c. So I'm going to multiply. X squared minus 26x minus 56. Now I've got to look for numbers that multiply to negative 56 but add to negative 26. Now I know that half of 56 is 28. So if I have a negative 28 and a positive 2, that's going to give me negative 56 and negative 26. So I've got x minus 28 times x plus 2. I can't leave it like this because that's not going to get me back to my original. I moved my a to become part of my c, and now I've got to take it back out. So I'm going to divide by my original a and simplify my fractions. 28 over 8 simplifies to 14 over 4, or 7 over 2. 2 over 8 simplifies to 1/4. Can't leave a fraction, so I do bottoms up. So we've got 2x minus 7 times 4x plus 1. Over here, we're going to do reverse box. Always look for your GCF first. 10, 12, and 2, I have a GCF of 2. So I take out a 2, that leaves me with 5x squared plus 6x plus 1. First thing I'm going to do is go ahead and multiply my a and my c. 5 times 1 is still 5. Draw my box. First term always goes up front. Now remember, I'm just factoring this because I already broke down my first line to get this one. So I'm just factoring what's in parentheses. So I've got 5x squared and a positive 1. My last term goes in the bottom. I'm looking for two numbers that multiply to 5 and add to 6. I know that those are going to be 5 and 1. So I'm going to have a 5x and a 1x. Don't forget your variables. I'm working from that bottom right corner. My GCF with 5x and 1 is 1. 5x squared and x is x. 5x squared and 5x is 5x. And 1x and 1 is 1. Once I have my GCF, I just need to write in my parentheses. So I have an x plus 1 and a 5x plus 1. And that's it.